We're now going to add extra functionality to our BLE demo. So this is more in the lines of what you'd probably be wanting to do for your own application. So we're going to have a bit more of a closer look at the BLE middleware, so the WPAN that we included earlier on in our previous hands-on, and we'll have a bit more look at the architecture of what's inside that middleware software package that we're using. And we're going to add our own service with our own characteristics to extend the profile. So we're going to be playing around with these unique IDs for each of these services and create our own service specifically designed for our target board. So that's where we finished up with our P2P client running on our phone side and our P2P server running on our Nucleo board side. So now we're going to add some form of environmental sensor. So we're going to send out, in the case of ours, we're going to send out some temperature data from our Nucleo board up to our mobile phone. So it's going to be extension on what the P2P server application is doing. And to do this, we have to also unlock these extra screens that you're seeing there on my slide in the phone app. So we'll show you how all that information gets created in our Nucleo board software. So the top half of the screen is showing what we had. So we had our P2P primary service with our two services or secondary services underneath, P2P write and P2P notify. Now we're going to add a new service, so what's labeled there as our very own service. Our service will have characteristics and it will have some sort of descriptor to explain what we're doing with those variables and what we're allowed to do with those variables that are part of our brand new service we're going to add. So how it's going to work, we're going to send periodically a value at 10 Hz update rate of temperature information from our peripheral or GAT server to our central, which is our GAT client, and the app running on our mobile phone. So we're going to send out notifications from our peripheral to our central device. To do this, we're going to resync everybody again. So we're going to open a brand new CubeMX file, which is hands-on_number3, just to make sure for those of you who fell a bit behind or got something wrong in the previous example, everybody's back to the same starting point of these. If you did fall behind, then in one of these subfolders in the STM32WB workshop, the subfolder is called Extras. You do have all the solutions for each of these individual hands-ons that we're running. So you can go and look at the completed file if you have managed to fall behind. So let's go and now have a look at our hands-on number 3. First thing we need to do, we need to terminate our debug session that we had running. And again, I'll be nice and tidy in my Atomic True Studio, and I will close my previous project to make sure I don't have any conflicts with different main.c's for editing. And then I'll go back to my CubeMX and I can go File, Load Project, go up the tree one and into hands-on number 3 and load my IOC file. So this should put us on the pinout diagram, which was where we left off on our previous example. So our two oscillators are visible, our RF is visible, along with our push button, our two LEDs, and our UART and debug functions. So because we're only adding BLE functions, we can go straight into the middleware section and click on our BLE information. I'll resize my screen a bit so I can get a better view. And we're still in the server profile, and now we want to add a custom template. So we need to change our custom template to be enabled. So that we're differentiating between everybody's different boards and that, we'll give our board our magic number. So again, down here we have our local name. We need to put our magic number or our happy number into there. So for me, it's TT for the trainer. So I'm TT-node. And that's all we need to do. So we've added the custom template, and we're now going to create our project. So we can move across on the tabs at the top here into our project manager. And we need to click on the project on the left-hand side. Because we've opened a project again, our project name and our project location should already be correct. As to should our toolchain IDE, which is True Studio. The tick box here for generate under root should be present as well. And then down here at the bottom, we are still using the correct version of our library. So there should be nothing for us to edit in that project manager. And now we can hit the big blue button on the right and generate our code. When you're prompted, we can open our project again, and that should now automatically launch our Untitled True Studio. If you accidentally closed it, again you'll be presented with the selection of the location for your workspace, which is still STM32WB _ workshop on the root of C. And when you've done that, you should now be in your IDE again. I'll expand my file here just so we can see the information that we've got. So this is what we had before and after the adding of our custom template. So we've only actually gained 2 files in the .h's and the .c's to what we had previously. So we've now gained something called template _ server _ app.h and .c. These are in our normal project workspace, and they relate to the same file called p2p server app.c and .h that we were editing in our first hands-on. We've also gained another file in our middlewares. So another file has been linked in or copied in from the middleware source files into our project source file for the middleware, and that is called template _ stm. And again, there's a .c and .h for that one. And as before, it is also linking to the same ones we had earlier, which was p2p _ stm .c and .h. So everything seems to work in matching pairs with these services. So here's more of the explanation. So the template _ stm are the GATT service configuration layer and initialization layers that cover all the characteristics, the update functions, and the unique IDs. It's also where the GATT event handler is located. The template _ server _ app is your application part. So this is where your application layer is sitting. And this is where all the services related to the events handling, so the notification event, the write event, and things like that. So they all sit in this template server app.c and .h. And as I say, they do mirror quite nicely the p2p _ stm and the p2p _ server _ app. When you start doing this type of service and you want to add more of these, then once you've generated the template one, you will then have to go into both of these subfolders and rename them from the word template to something that's appropriate to you. So in the middlewares, you'll need to rename template _ stm to something that's relevant to you, and same with in your main project folders, they will need to be renamed. And then once you've renamed them, you can then go back into Cube and generate another new template server. So if you're adding 2 or 3 extra services, you follow this process and then rename. So if we look in our source files now at app.ble, in our app.ble.c file, right at the bottom of the includes, you will now see a nice new include for template underscore server underscore app. And then further down that code, you will see the initialization of our template underscore app underscore init. So at this point, we can actually go and test out our functionality. So we'll now go and build our project and debug our project and run it and connect our mobile phone to our project. So I'll go back to our Atolic. I'll highlight hands-on number 3 because at the moment I'm highlighting hands-on number 2 and all my buttons are grayed out. I'll highlight hands-on 3, build the project. Start the debug process off. Run the application. So if I now go to my mobile phone, and I can now start the application, search for new devices. Because we're playing around with different characteristics here, and we'll be changing these characteristics quite frequently in this hands-on, and the Android phone app, to save time, caches some of the data. So we have to make sure in the Android app that we clear the cache. You don't have to worry about it if you're using an iOS phone. They tend to do that automatically for you. So we need to, before we connect, we need to clear device cache so that every time it will go and reload all the information about this node rather than just saving the information. So then highlight the node, we'll connect, and we'll get our screen as we had before. So your previous functions will work that you had there, but there's no new functions currently visible at the moment. So I've now changed my phone app for the BLE sensor to one that contains debug information. So I need to resume my running behind me. I'll now start scanning. Yep. And select my node. So now in my menu I now have a debug feature, and you can now see if I expand template that I have a new service running on my mobile phone compared to just the P2P service we had earlier, and inside there you can see the primary service UUID, the template right secondary service UUID and its values, and the secondary service for template notify and its UUID and values, and any descriptors that are relevant to that notify service are also visible there. So this extra debug version of the app is available to you. It was extracted from the large zip in the extras folder, I believe. So you do have this older version, so it's not the latest version now. I think the web version has increased to 4.2, but if you do want to have access to this debug version of the app, then you've got a copy as an APK in that installation folder already. So what do we want to do? So as you saw there, the app is not recognizing our new template service, even though we've enabled it. So what we have to do in our software, we've now got to align the advertising data and add the specific characteristics to tell our central GAT client or mobile phone that we have environmental sensor information we want to provide to you, and our application on the phone, the BLE sensor APK, has the ability to read that information, and it will unlock new screens for us in our phone app. So we now need to go and have a look at our advertising structure. So this is one of the AD structures of our BlueST protocol that makes up part of the advertising structure, and we're interested in these 4 bytes that make up the feature mask. So these are the features of our ST protocol that we're going to transmit up to our mobile phone so that our phone app can understand it. Again, all of these are detailed in the BlueST protocol, which is available on GitHub. So if you have a look at the different feature masks that we have available, we want to send out temperature. So temperature is bit 18. So we want to enable bit 18 so that we can send out our temperature data to our mobile phone. So now we go back to our advertising structure that we saw earlier, where we looked at the protocol version, our configuration development ID for our P2P server, and we're now going to add some of these extra features which make up Group A and Group B. So our bit 18 means that we need to put a 4 into the second part of our Group A feature set, so that we can make our advertising packet tell our phone that we have these extra services available. So if we go back to our code, I will terminate my debug session, and I now need to go into app BLE.c, and I need to scroll down to line number 243. So there's our structure now for our manufacturing data, and there's our Group A and Group B. So it was the second half of our Group A that we need to have a 04 in it, which ties in with our mask for bit 18 to be set to 1. Change that to a number 4. So what do we need to do next? So we've now set up the mask, but it's still classed as an unknown service. So we won't recognize the service until we've given it a UUID that our client can recognize. So now we have to go and locate the template service file. So this is hidden quite well or quite deep into our middleware stack. So you have to follow this path through on the screen now to try and locate template STM.c. So it's in our middlewares, ST, WPAN, BLE, core, source, BLE services, and there's our template underscore STM.c. So as I say, it mirrors our P2P STM.c. So we want to open the template version of it. And now we need to give our template primary service a unique ID. So we need to modify line 87 of this file with our unique ID. So again, we've got our hyperlink there for the modify. So if we open our hyperlink, so there's our UUID that we need. So this is going to replace the top one of the 3 IDs at line 87, 88 and 89. So I will copy all of that. And then in our code at line 87 of this file, we will find our UUIDs. There it is. And if I scroll to the right, I need to replace this numerical string here. So for some reason the file is a write only, so we have to say yes to make it writable. And again, that's just a safety feature of the file. So now my new file has gone in. So that's defining our primary service. And now we need to make the characteristic for that service recognizable. So our UUID is now telling us it's an environmental sensor from STM, but we don't have a characteristic UUID. So we now need to add the UUID for our characteristic, and this is line 89. So it's the template notifier UUID. So in this particular service, we're not doing a write. So we're not using line 88. So we're not doing a write UUID. We're only doing a notify. So it's only line 89 we now need to add. So if we open our next hyperlink, we'll get our second UUID. We copy that, and in our italic we go to line 89 and do the same again. We overwrite the template with our unique UUID. So now we can go and test the functionality again. So we highlight our hands-on number 3, we rebuild our project, we enter debug mode, we resume our application, then we go to our phone application, start the scan. Again, we're Android, so the information was cached from previous time, so we need to clear the cache, launch our connection to my TT node, and now straight away I have new information or new pages available to me based on those unique IDs. So we now have environmental temperature information available to us, and if I swipe across, we'll have the graph information again for the temperature information available to us. If we swipe across one more time, we'll get to our default page we had earlier, which was our LED control. And if you test your LED control, you will find that that still works. And if you press your button, you'll see that that is still functioning on your target software as well. So while we're in there, I can then go back to my debug information as well, and now that has changed, and you can see that we have our environmental sensor visible based on our UUID, and you can see the template write STM, which is the one we didn't modify, but you can now see that the notify one is now temperature STM. So that UUID has come through, and we have a default descriptor available for our notify as well as being 2 bytes. So you can see all that information from the debug screen that we have there. So if I back out of that, so now we need to send some information. So there was no data being transferred at that point, so you could only see the advertising information and then the exchange of UUIDs to decide which characteristics we had available. So our packet that we want to send 4 bytes. So we want 2 bytes for a timestamp and 2 bytes for a temperature reading. So we now need to align those in our characteristics. So we've got to start editing our characteristics so that we know exactly what we're sending, and so the phone app knows exactly what it's expecting to receive. So again, in our template underscore STM, we have the services that we're providing for our temperature transmission. So we have our primary service there, which is doing the environmental information. So there's nothing to change in the primary service. But in the secondary service, which is telling us the temperature readings, we now need to modify our notify characteristic. So we're doing nothing with the write characteristic at the top because we're not using that function in our application here. But we are going to change the notify characteristic that we're using in the bottom half of that function. So at the moment the value is set to 2, and we're going to need to change that because we now want to send 4 bytes into ours. So we need to now go and find that notify characteristic in our template file. So if we now go into template_stm.c and scroll down to line 229, so I'll terminate my debug session first and go on to our template stm down to line 229. Scroll all the way back across. There we can see our notify characteristic, and we need to change our value there from 2 to 4. As well as the notify characteristic, we've also got to change the update characteristic as well. So again, it's in the same file. It's a bit further down at line 271, and we have to let the update characteristic know that we're updating 4 bytes, not just 2. Scroll a bit further down there, we'll find our update characteristic, and that needs to change from 2 to 4 as well. So now we need to build the structure for our 4 bytes. So now this is back into our application side of things. So we're finished in the services side of things in the middleware. So we're now coming to the file called template_server_app, and we need to create our structure for our new 4 bytes that we're going to add to our system. So we have our hyperlink there for our file, and we need to add our structure. I'll copy that, and that needs to go in the private type def above another structure which has got notification status in. So it's line 28 of our file, and we are now looking for our template server app.c, and it's at line 28. So there's our type def structure that's there. So we have to put this new structure in just above our existing structure. And we now need to add 1 new value to that existing structure that we've just added our new structure above. So we need to add that line in as well. So we'll take that line, close that now, and that goes in there, in that one. So we've got to initialize those 2 new values that we've created. So we now need to add into our template context initialization. We've got parameter already there, and I've now got to add 2 more new variables to our initialization window. So again, we'll go to our hyperlink there, number 4. And they need to be added at line number 131. So there's our template app context initialization. So they go in at this point here. Now we need to send the update characteristic function so that when we send our notify that there's a task happening, we send all our bytes now. So we're going to send our 4 bytes. So we need to add this section at line 138, which is the send notification task. So this is starting to build up the payload of what we're going to send as our values outbound. So if we open our hyperlink, there is our structure. We copy all of that. And now this goes in at line 138 in our notification task. So there's our notification task. And it is going to overwrite the template version. So that's our existing template one. So we're now going to overwrite those two lines with our new structure. So now we need to register this task. So we've got to register a notify temperature task, and we have to create it. So we've got to do our task ID, and then in our app initialization, so our template app initialization, we have to register the task so that the notification will get sent through to our mobile phone. So if we click on our hyperlink there, we can see we create our identifier for the task. So this needs to go at about line 455 in app.conf. We go to app.conf, and it's app.conf.h, not .c. So expand my include, so app.conf.h, and it was line number 455. There's our configuration task ID. So that goes inside there. And now we've declared our task in the configuration file. So now we can register our task in our template server app.c file to register it and link it to the notification. So I'll take the comments as well. Close that file, and that's at line 116 of our template server app. So you go up a bit, at line 116, and we paste it right at the top of that. So now we can go and test our functionality again. So I'll highlight my hands-on number 3. I'll rebuild my project. I have an error there as well. From the copy and paste, it's missed off the word task on the end. So if I build again, I can enter my debug. Start my software running, and now if I go back to my mobile phone, I'll launch my sensor app, I'll start my scanning, I'll remember to clear my cache again because I'm an Android based phone, connect to my node, and we've now got our services aligned, but we've still not set anything up to send any data across yet. So we've aligned all the services, we've got the notifications set up ready to transfer the information, we've just not created any information to transfer yet across to our phone yet as our application. So what we need to do next now is to send periodically our value out at every 100 milliseconds. So we now need to define some constants to create our variable. So we don't have a temperature sensor attached to our target board, so we've got to create the values that we're going to send out. So to do that, we have to create some constants. So if we click on our hyperlink here for defining our constants, so we'll copy all our constants there, close that, and that goes in at line 42 in our template server app. So I'll terminate my debug session first, template server app up to line 42 and create our private defines. Now we need to create a new value so that we can change the step, so that we can increment our temperature value every time we rotate round our loop. So we have to add a new value into our structure for change step. So this is at line number 35 in our app server, template server app.c. So it goes after our temperature variable there. It's actually at line number 40, not at line number 35. And then we need to add this into our context initialization as well, down at line number 140. So if we go back to my text file, get the next, paste, and close that now. So this is down towards line 40, so line 140. And that one goes after the temperature value, so it goes in at line number 143. So now we've got the routine that will periodically change the value. So this is to send the information out using the change step that we've just created. And this again goes in our send notification area. So it goes just below our declaration for our values for our 4 bytes. So that's on hyperlink number step 9. And that goes in at line 148, or approximately line 148. So it goes after all our declarations there for our values, so it sits there in our structure. So that we get the updates coming through, we're going to use another feature that's built into our middlewares, which is our time server. So you can have up to 255 virtual timers running in the library stack. It will take up a reasonable amount of RAM, so chances are you probably won't be able to get 255 in, but it means you can do single shot timings, repeated modes, you can start and stop, you can delete timers. So again, it's similar to what we have with the various low power modes and the various tasks. You can set them up, you can have the same structure with it. This is all being run by the RTC wake up timer. So this is the reason why we need the 32.768 kilohertz low speed external crystal in our system. The API command list for our time servers, again very similar to the tasks, so you can create them, you can initialize it, you can start and stop them, you can set them to be wake up events, things like that. And you can do this anywhere inside your software routine. So you can start a virtual timer at any point, you can stop a virtual timer at any point, if it hasn't already expired. So again, you've got the flexibility on what you want to do with these virtual timers, and they're not using all the hardware resources of the STM32WB for this feature. So we need to now create our software timer for our periodic triggering of our task to generate our update notifications. So here we have in our template app initialization, we're going to register a task, which we've already done, and now we're going to create the timer that is going to change the information that we're sending. So if we go to our snippet section 10 to open our section of code, and that has to go at line 123 or approximately 123 in our template app initialization. So if we scroll up, so there's our template app initialization. So it comes after our register task. Yeah, and it comes before we have the server app context. Paste it into there. So we now need to update our structure to add the update timer ID into our structure. So this comes after the change step line that we've added. I take my hyperlink. And go back up this file to my structure definition, and it goes in at line 41, so after the change step. And now we need to do the callback for the software timer. So when the software timer expires, like all our HAL libraries, it will trigger the callback. So we now have to declare our callback routine in our function prototypes, and then we have to actually specify what our function is going to do. And in this case, it's going to schedule a task which is going to call the config notify temperature with a priority of 0. So if we go into our next hyperlink, so we're going to add that into our private functions prototypes. In our private functions prototypes, we'll add our define, and then the second one wants to actually go into the private functions themselves, which is the structure of our prototype. So if we go back to our software section, take that, and that should now go into private functions, which is here at line 67. There we go. So that's our callback routine, which is going to schedule our task. And then finally, we need to start and stop our software timer somewhere. So this is done in the app notification section. So we have our template notify enable event and our template notify disable event, and in there we need to put our start and stops for our timer. So if we open our last code snippet hyperlink, step 13, so we'll take our start event, which goes into our notification, and it goes just before the break of notify enable event. So here's our notification, and here's our notify enable event, so it goes after the end if. Sits in there, and the disable event goes in the STM notified disable event, and again just before the break. Take that one, close that down. There's my disable event, and that goes inside there. So now we can build our application, and hopefully we should now see some temperature data arriving in our mobile phone. So I'll highlight my project and build. I will enter my debug. I will start my application running. I'll then go back to my mobile phone, launch my BLE sensor app, scan for my node. There's my TT node. And now we have our temperature sensor coming through to our mobile phone. So we're receiving the temperature information. And if I swipe across to my graph and hit the play button, we should now see that same temperature information relayed into our graph function. And just to prove that we're seeing it, I can also go into my debug and expand my environmental sensors, and you can see the values changing there inside the debug element as well. So it is all visible to all parts of the application. So if we just look a bit more detail at this firmware that we've been using, the BLE-WB, you can see here the various utilities. So we've got the low power management, the OTP, the scheduler, the queues, the list, a few debug traces. And inside the actual middlewares, you can see some of the extra functions as well for the HAL ACI commands, for the GAT ACI, the GAP ACI commands. So you can see all those extra files that are included inside the middlewares. So one of the other areas we've not had a look at yet is the low power management. So again, the low power management, just like the scheduler and the timers, the hardware timers, again it gives you multiple ways of entering and exiting the low power modes that we've got available. So you can start and stop low power modes. You can have different functions to say that you want to enable or enter low power mode based on what you're doing. And again, the API command set is there, so you can say if you want to enter sleep, stop, or actually go offline completely. So you can set these different modes and again call them in your scheduler. So if you can see there, as soon as you enter schedule idle, you enter low power mode selected. So whichever low power mode you've previously selected is the one that you'll go into. So where do you go next? So we've just had a look at our latest repository, which is version 1.0.0. There's lots more information about the various specifications on the Bluetooth SIG that you can go and have a look at. And for the apps, if you want the source files for each of our apps, then they're available on the GitHub. So you can go and download the iOS app and the Android app that we've been using today to do our hands-on workshops. So if you want the source files as your starting point for any of those apps, you can go and download them directly from the GitHub so you can have a play. So there's various examples available in the package. So we have the Bluetooth SIG adopted applications. These are things like blood pressure, heart rate monitor, human interface device, beacon and things like that. And then we've got our proprietary ones. So cable replacement, data throughput, the P2P server we were playing with earlier. P2P router, you'll see that in some of the demos later on. And same with transparent mode as well. So this is how you use and test the RF functionalities on your PCB. So they're proprietary based ones, but we have adopted some of the Bluetooth SIG ones already. Of all the different profiles that you can have, most of them will work on our Nucleo board, and only a small amount will work on our dongle board that was included in your package. The reason not everything can work on the dongles is there's not enough periphery on that dongle board to do some of these functions. So it depends on what you're doing in your testing, and application will depend on which profile we have available for our Nucleo board or for our dongle board. So this was the flow that we had going on. So we came into our main.c, initialized all our hardware, and then started our BLE, so which was API.init, or application entry initialization. That then goes into our app entry.c file, where we initialize various pieces of hardware, so things like LEDs, push buttons, and the callback routines for each of those bits of hardware, and the SRAM and the IPC are all initialized in there. Then we drop down into our app BLE initialization, which is in app BLE.c. So that starts off the communications, and it's where you configure the advertising and set of your discovery, and that's all managing the gap events part of it. And then you'll go into service control initialization, which is in svc control.c, and this is where you start initializing all the gap services that we have and we've been playing with during today. So that's the typical BLE application configuration and setup, and the flow of how the software works. So hopefully after this section you've now learned how to modify a GAT to set your own attributes up, set your unique IDs up. You've seen a bit more information about our BLE stack and what else is included in our BLE stack, and you know now where you can go and add extra things yourself to do what you want to do based on your application. Thank you.